Hello everyone, welcome to my channel. Now in this video is a continuation of my previous video. Now here I am going to discuss the two types of semiconductors, namely the intrinsic semiconductors and the extrinsic semiconductors. Now first is intrinsic semiconductors. Now intrinsic means pure, something in its pure form. So intrinsic semiconductor means a semiconductor in its pure form. Intrinsic, this term means a substance which is in its pure form. So in the lattice structure of this intrinsic semiconductor, you will have, if it is a silicon semiconductor, so 100% silicon. If it is germanium semiconductor, it will be 100% germanium. Now both silicon and germanium are group 4 elements, so they have a valency 4. So suppose let me draw the silicon structure. The silicon atom, silicon atom, silicon, silicon, silicon. So there will be covalent bond on all sides. So each silicon atom will form 4 covalent bonds with the 4 neighboring silicon atoms. So this is the 100% pure lattice. So in this lattice structure there will be only silicon atoms. Now if we see the band structure of this intrinsic semiconductor, this is the conduction band. So as we know, for semiconductors, the conduction band and the valence band, they are separated by small band gap. So this is a small band gap. Now at 0 Kelvin, we know that the electrons, their kinetic energy is 0. So this conduction band, it will be completely empty, and the electrons will be in valence band. Okay, so electrons will be occupying space in the valence band. So since the conduction band is empty, this intrinsic semiconductor at 0 Kelvin, it will act like a insulator. So now what happens when the temperature is increased? When the temperature is increased due to thermal agitation, few of the electrons, they will go from valence band to conduction band. Okay, so electrons move from conduction band, from valence band to conduction band due to thermal agitation. Okay, so the electrons, they move from valence band to conduction band due to thermal agitation, that is due to increase in temperature. Now obviously, suppose here you have electron. Now if this electron moves from valence band to conduction band, in place of this electron, now you will have, so this electron, now it has gone to this place, so here you will have a whole empty space. Okay, so that means for each electron moving from valence band to conduction band, there will be a formation of hole in the valence band. So this means that if Ne is the number of free electrons per unit volume, Nh is the number of holes per unit volume, for intrinsic semiconductors, this quantity will be equal. Okay, and this is equal to Ni, where this denotes the intrinsic carrier concentration. Intrinsic carrier concentration. Okay, one more thing. See, since in intrinsic semiconductors, number of electrons is equal to number of holes, movement of electrons gives rise to current which is due to flow of these electrons. There will be also equivalent current due to flow of these holes. So the total current in intrinsic semiconductor, it is due to flow of electrons plus flow of holes. Okay. So now, but this flow of current is due to formation of these electron holes pair. But why this electron holes pair were formed? Due to thermal agitation. So that means the conductance of intrinsic semiconductors is dependent on temperature. It is dependent on temperature. Okay. Now, so because of this, intrinsic semiconductors, it has got some shortcomings. It can't be used for making electronic devices. What is the reason? See, one reason is they have low conductivity. Low conductivity. Okay. The other thing is the conductivity is temperature dependent. Conductivity is temperature dependent. Okay. The other disadvantage is, see, here current due to the electrons is equal to current due to the holes, and we know that these two currents are flowing in opposite direction. Okay. So net current, it is very difficult to get a net current in case of intrinsic semiconductor. Now why I equal to IH? Because Ne is equal to NH. We have equal number of electrons and holes. So we have equal amount of current due to electrons and current due to holes. So these are few demerits for which intrinsic semiconductors can't be used for designing semiconductor devices. So for this we have extrinsic semiconductors. So now let's see what is extrinsic semiconductors, how it is different from intrinsic semiconductor, and what is the benefit of using extrinsic semiconductor. Extrinsic semiconductors. Now, in intrinsic we had pure form of silicon or pure form of germanium. Now, this intrinsic semiconductor it is converted to extrinsic semiconductor by doping. Now what is doping? Doping is the process of addition of impurities. Okay, but see, it is not that just like that you can add some impurities. You have to add impurities, like choiced impurities, means you want to improve a particular quality, you will be adding a impurity of a certain type. Okay, so addition of choiced impurity, that too in a measured quantity. Why we are adding impurities? To improve on these quantities. See, extrinsic semiconductors has these demerits: low conductivity, conductivity was temperature dependent. So we don't want all those things. So we want to increase the conductivity. So for that we are adding impurities, and that process is called doping. So doping is the process of addition of choice impurity to improve conductivity. Okay. Now based on the nature of impurities added, we have two kinds of extrinsic semiconductors. One is N type, the other one is P type. Okay, so intrinsic semiconductor is converted into N type extrinsic semiconductor or P type extrinsic semiconductor based on this doping, addition of choiced impurity. So addition of a particular type of impurity will lead to formation of N type semiconductor. Addition of a different kind of impurity will lead to the formation of P type semiconductor. So now we will see, first we will see N type semiconductor, formation of N type semiconductor. Now N type semiconductor is formed by addition of pentavalent impurity. Pentavalent impurity. Okay, so now let's see how this happens. Okay, now in the silicon structure we will add this pentavalent impurity, will add like phosphorus. It has valency 5. So suppose this is phosphorus, so this is silicon, this is silicon, this is silicon. Okay, so now phosphorus will form 4 covalent bonds with the 4 neighboring silicon atoms. Okay, but it has 1 excess electron. Okay, so addition of this impurity leads to creation of 1 excess, not creation exactly, formation of 1 excess electron. So there is an excess electron. So that means for every phosphorus atom added there is an excess electrons. Okay, but by virtue of this electron there is no hole created. Okay, so no hole created. Okay, and this number of phosphorus atoms is equal to number of electrons. That means the more the number of electrons you require, you add the number of phosphorus atoms. So that means you are not now able to control the number of electrons, or number of electrons are the charge carriers. So earlier we had Ne equal to Nh in intrinsic semiconductor. Now Ne is not equal to Nh. Electron concentration is not equal to the hole concentration. Okay, and since phosphorus is donating electron, okay, phosphorus, it is donating electron, so here it is called donor dopant. Dopant means impurity, and it is donating electron, so it is a donor. Okay, what is it? It is donating an electron. Okay, so now in the valence band diagram, if you see, suppose this is the valence band and this is the conduction band. So the electrons of the donor electrons, they have, see, these electrons have energy corresponding to these phosphorus atoms. So now these electrons, the electrons donated by this phosphorus, this excess electron, they have energy just below the conduction band of silicon valence band diagram, that the band theory. On band theory you have this conduction band and the valence band. So electron energy is just below the conduction band. Okay, this is the energy of donor electron. Okay, it is just below the conduction band. And okay, now already with this we know that Ne into Nh, this is equal to Ni square. Okay, number of electrons per unit volume multiplied by number of holes per unit volume is equal to square of the intrinsic charge carriers per unit volume. This term is constant. Okay, now here on addition of electron, see, Ne is not equal to Nh, and Ne in fact it has increased because number of electrons has increased. Now if Ne increases, that means Nh has decreased because the product has to be constant. So for N type semiconductor, number of electrons per unit volume, it is greater than number of holes per unit volume. So that means electrons are the majority charge carriers. Now since number of electrons is more, the current due to flow of electron will be much greater than the current due to hole. So electron current, it is greater than, in this case, hole current. Okay, and here electrons are the majority charge carriers. So this is intrinsic semiconductor. So next let us see the p-type semiconductor. A p-type semiconductor is obtained by addition of trivalent impurity. By addition of trivalent impurity like aluminum, indium. Okay, group 3 elements. Basically these are group 3 elements. Okay, so now let us see the crystal structure of this p-type semiconductor. So we have added impurity aluminum. So here we have silicon, 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 4 silicon atoms. Okay, now here aluminum has valency 3, so it will form 3 covalent bonds with 3 neighboring silicon atoms. So no electron is available for this silicon to form covalent bond. Okay, so that electron will leave this space, leaving a hole. So this is the hole. Okay, so that means for each aluminum atom added, there is a formation of hole. Okay, now like electron we assign a negative charge, so absence of electron we will assign a positive charge. So hole we will assign a positive charge. Okay, positive sign. So hole is positively charged. So now see here what happens, the number of aluminum atoms added, for each one aluminum atom added, there is a hole. So that means number of holes it is equal to number of impurity atoms added. So in this case it is aluminum. Okay, so obviously in this case number of holes per unit volume will be greater than number of electrons per unit volume. So here holes will be the majority charge carriers, holes majority charge carriers. Okay, now here since aluminum impurity is accepting the electron, so aluminum in this case it is called the acceptor dopant. Acceptor dopant. Okay, so this is p-type semiconductor. Now with regard to the band theory, this is the conduction band, this is the valence band. Now here the electrons, the acceptor electrons, they have energy just above the valence band. Okay, slightly above the valence band. In p-type semiconductor you have the acceptor electrons whose energy is just above the valence band. Okay, so this is the in detail we have discussed p-type semiconductor, formation of p-type semiconductor. Now let's see what are the advantages. Okay, advantages of p-type. One is better conductivity, better conductivity. Okay, now conductivity is not temperature controlled. Conductivity is not temperature control. See here conductivity is dependent on number of electrons or number of holes formed, and we have seen that it is now controlled by the number of impurity atoms added. Okay, so now the conductivity is not temperature control, but it is in our control. It depends on what kind of impurities we are adding and how much concentration we are adding the impurities. Okay, so here IE in both cases, whether it is p-type or n-type, I is not equal to IH. Okay, IE and IH are controlled by nature of impurity added. IE and IH controlled by nature of impurity added. Okay, so it is for all these reasons extrinsic semiconductors are preferred for making electronic devices. So this is the discussion of intrinsic semiconductor, extrinsic semiconductor. Then in extrinsic semiconductor we had two types, n-type and p-type. Now this entire discussion is based on your NCERT textbook. I have prepared these things from your NCERT textbook. I hope this video is beneficial for the students. Good luck.